Hello, Algebra 1 students, and welcome to Lesson 7.4 on factoring polynomials. So yes, we are going to finally learn what it means to factor polynomials. And I'm going to suggest, right, that factoring is the opposite of multiplying or distribution. So it's very much like division. So I'm going to put division in parentheses, like division. I'm also going to, in parentheses, put the word parentheses, because as you might recall, parentheses, I think so, as you might recall from the last 2 days of work on 7.2 and 7.2 day 2, we were given a lot of parentheses and we did a lot of multiplication to get rid of those parentheses. Well, now you're going to see that these problems have no parentheses, but when you are factoring, we're going to gain parentheses. Okay, so again, it's like going backwards from what we've been doing. All right? All right, so let's take a look. Okay, so it says find the greatest common factor. So what is the greatest common factor? GCF. You're going to hear us use GCF a lot. Greatest common factor of the terms 12x to the 5th plus 8x to the 4th minus 6x to the 3rd. So greatest common factor, again, when we factor, it's like division. So I have three terms here. I have a 12x to the 5th. I have a positive, I'm gonna space them out quite a bit. I have a positive 8x to the 4th, and I have a negative 6x to the 3rd. So I'm going to do this the first time, and then we'll never do it like this again. But I'm really going to explain what it means to factor. So what we're going to do is we're going to take each term, we're going to break the number into its prime factors, and then we're going to break down the x's, right? So what is 12? So I know that 12 is 2 and 6. 2 is prime. I know that 6 is 2 and 3. Both of those are prime. Okay, so I'm going to break out each number. I know 8 is 2 and 4. 2 is prime. I know 4 is 2 and 2. They're both prime. And I know 6 is 2 and 3. Okay. All right. So now I'm going to rewrite each term in its expanded form. So 12 is 2 times 2. I'm sorry, 2 times 2. I'll put the jump right. 2 times 2 times 3. I apologize. 2 times 2 times 3. If you multiply those, you get 12. And then x to the 5th is x times x times x times x times x, 5 x's. Okay, so that is 12x to the 5th written out as an expanded form. Okay, plus. Okay, 8 is 2 times 2 times 2. Again, if I multiply those, I'd get 8. And then x to the 4th is x times x times x times x, 4 x's. Minus 6 is 2 times 3, and then x to the 3rd is x times x times x times x. Okay, those are all times. Okay, so what I want to do now is I want to circle everything that is common to all three terms. So let's start with the numbers first. So I have a 2. Let me do this in blue, right, to kind of make it stand out. I have a 2, I have a 2, and I have a 2. Now, the second 2 is in the middle term, but there's no more 2's in the last term, so I'm not going to circle them or 2's. 2's are done. Then I have a 3. Oh, but I'm not going to circle that. Why did I do that, Mr. Chappell? Because the middle one doesn't have a 3, so I'm not going to circle that. So I apologize. I'm not going to circle that. Sorry to waste your eraser, right? Just me just assuming things, right? And now if I look at the x's, right, I have one x that's common, x, x, x. I have two x's that are common, x, x, x. And I have a third x that's common, x, x, x. But notice there's no more x's in this last term, so there are no other x's. So if we look at everything we circled from each term, we circled a 2 and 3 x's. So our GCF is going to be 2 and then 3 x's, which is x to the 3rd. When we write this down, we're going to put it out in front. 2x to the 3rd. There's our GCF, and there's that parenthesis I talked about. And now, if I were to cross all of those off from every term, I am now just going to write down what's left over for each term. So this first term is a 2 times 3, which is 6, and x times x, which is x squared. Plus, the middle term is a 2 times 2, which is 4, and an x. Minus, and the last term is a 3. And now again, inside this parenthesis, none of these three terms have any common factors. 2x to the 3rd was the greatest common factor, and we're done. And this is what we're trying to do today. Pull out the GCF. Okay, so again, this is the only time I'm going to expand it like this because hopefully we can go a little faster as we go through. We're going to teach you some tricks on the next one. Okay, next. Okay, so we're going to factor out the GCF. All right, here we go. Okay, so again, I don't care. We're just going to do the GCF. I don't care about the sums. Okay, so if I look at these terms, so negative 12x to the third plus 18x squared minus 27x. If I start with the numbers first of all, right, your leading term is negative. That means that our GCF is going to be negative. So again, leading term or first term. If it's negative, then our GCF is negative. And now, I'm going to look at the three coefficients, 12, 18, 27. The smallest one is 12. Okay? So what I'm going to do is I'm going to look at 12 and say, okay, what numbers in 12 go into 18 and 27? All right? So we can do this a couple weeks. We can stick with just 12, or we can break 12 down if you want to. Let's break 12 down into its primes. So 2 and 6, and then 2 and 3. Okay? Now, let's start with this 2. Can all numbers be divided by 2? So 12 can, 18 can, but 27 cannot. So these 2's cannot be part of the GCF. Okay, now what about 3? 3 goes into 12, 3 goes into 18, 3 goes into 27. That means that 3 is going to be in your GCF. So your GCF is going to have a 3 involved. Okay? Because 3 divides into all 3 numbers. And now if we look at the x's, we have x to the third, x to the second, and this is x to the first. You can only keep the smallest number of x's possible. So in this case, x to the first is the smallest number of x's. That's 1x. So that's going to be part of your GCF. And we have it. Negative 3x is our GCF. So now I'm going to pull that out. Negative 3x. And now what we're going to do is the following. We are going to divide our coefficients by negative 3. So we're going to do two things. So the first thing is we're going to divide the coefficients by negative 3. And the second thing, we're going to take the exponents of x and subtract 1 because this is 3x, the negative 3x to the first. And then the negative, as a bonus, is going to change the sign, but that's going to be taken into account when we do this division, right? So your signs will change. So we're going to have sign changes. So sign changes. Okay, so negative 12 divided by negative 3 is 4. X to the third, subtract 1 is x to the second. Positive 18 divided by negative 3 is negative 6. X to the second, take away 1 is just x to the first. Negative 27 divided by negative 3 is positive 9. X to the first, take away 1 is x to the 0. The x goes away. Your positive 9 is now a constant. And this is your simplified polynomial by pulling out the GCF. Negative 3x times 4x squared minus 6x plus 9. Now, before you circle your answer, you should double check to make sure there's no more common factors. Make sure all 3 terms don't all have x. Make sure that the smallest number 4, its factors can't go into the other 2. So 4's factors are 2 and 2. 2 goes into 6 but not 9, so we're done. So that is the answer. And again, this just kind of talks about why it's important to pull out the common factor. So it says factoring out the GCF, right? Factoring out the GCF can result in smaller coefficients with smaller exponents. Smaller coefficients. It's not, let me hold on just a second. Let me drag this up real fast. So smaller coefficients with smaller exponents. And again, in math, sometimes it's easier to look at smaller things than bigger things, right? Right, I'd rather deal with a single-digit number than a double or triple-digit number. Perfect. All right, last one here. Short little notes here. All right, so again, we talked about factoring or multiplication in areas, so we'll do the same thing here. So it says the areas of the rectangles are given. Use factoring to find expressions for the missing dimensions, right? So we are going to do factoring using the GCF. So it says use factoring, and again, it's going to be GCF. Now notice that in this picture, Each of the rectangles has a parenthesis itself there, but then a question mark. But then this question mark is actually also over here as well. Works for both rectangles. So this question mark right there and there, that is going to be the GCF. And then what's left over is going to go up here. So this is just a GCF question. Now, you can put a plus sign between them. You can just let them hang out. I'm going to put a plus sign just because that's what I'm used to seeing. So we're going to say this is 9xy squared plus 12x to the second, y to the third. And you're like, Mr. Chappell, there's x's and y's. Well, that's okay. That's okay, right? We just deal with each variable at a time. So let's start with the coefficients. So 9 and 12. So 9 is my smallest coefficient. So let's call GCF over here. So let's work with the 9, right? So 9 can be broken down into 3 and 3. So 3 can go into 9 and 12. Very good. Can a second 3 go into 12? Well, 12 divided by 3 is 4. 4 is not divisible by another 3, so no. So one 3 can go in, but the other 3 can't. So we know that our GCF has a 3. There's no negatives, so don't worry about negatives. And now we look at each variable at a time. So this is x to the first. Don't let that 2 go with the x. It's x to the first, has no exponent. X to the first, x to the second. We take the smaller number of x's, so that's x to the first. And then we look at the y's, y to the second, y to the third. We take our smaller number of y's, so that's y to the second. So our GCF is going to be 3xy squared. So I'm going to put that out in front, 3xy squared, open a parenthesis. And now we divide the coefficients by 3, and we subtract 1 from the x's exponents and subtract 2 from the y's exponents. 9 divided by 3 is 3. X to the first, take away 1, x goes away. Y to the second, take away 2, y goes away. That's just the 3. Plus 12 divided by 3 is 4. X to the second, take away 1 is x to the first. Y to the third, take away 2 is y. And here is our factored form. So the question mark on the far left, which is the GCF, will be 3xy squared. This top question mark, which goes along with the 9xy squared, which is my first term, will just be a 3. And then my second dimension, which goes along with the 12x squared y to the third, is 4xy. And there's your question marks. And again, if you were to multiply 3xy squared times 3, you'd get 9xy squared. If you were to multiply 3xy squared with 4xy, you'd get 12x squared y to the third. This is why factoring is the opposite of multiplication. All right, great. Thanks for watching. Good luck on this practice in class.